So there's two core libraries that are provided for OpenXLR8 that provide the foundation for running OpenXLR8 Flow: XLR8Core and XLR8BuildTemplate. The XLR8Core contains all the base libraries, scripts, source files that are needed to compile the entire FPGA design in Quartus. And then the build template provides a framework for the users to add their own custom logic. It's a template that you modify a few files here and there, and that allows you to bring in your own logic. To work within the Arduino IDE, we have to adhere to the library specification that they have. That leads to a file structure that's a little different than one might expect. Here we see, for an example lib, the files or directories that are required according to that specification. The examples and extras directories are optional directories. The source directory is where you would put all your C or C++ code, header files, that type of thing. And the library.properties and keywords.txt files are used by the IDE to provide information about the library and to highlight keywords in the source code viewer. What we're going to do is use the extras directory, that optional directory, as a place to store the stuff that we need for OpenXLR8. Starting with the build template library, we can see the top level structure here. It looks very similar to that example lib from the previous slide. We've got the source directory, we've got the keywords text and the library properties files. We include a license and a README file here. But you can also see that we have this extras directory here. And in it, we've defined 3 additional directories: the model sim, the Quartus, and the RTL directories. And a little bit more detail on that, looking in the extras directory, the model sim directory there contains files that are used for simulation. The Quartus directory contains the files that are used when compiling it in Quartus. And you can see on the listing over on the right here, there's quite a bit more files there than I list here. That's because we support 3 different boards and 3 different clock rates. And so there's some multiplication here of files to support all those different combinations. And then in the RTL directory, we've got a few files there that are templates or support files for building the OpenXLR8. Just to highlight a couple of these files that are either going to be edited by us or are important to know about. For each board, there's a board top.qpf project file. That's what we'll load in when we actually start up Quartus. The OpenXLR8.qsf file contains the specific directives for Quartus for this particular implementation of OpenXLR8. Usually what that is specifying the Verilog source files that are used in the custom logic. Over in the RTL directory, we've got our OpenXLR8.v. This is the top level module of OpenXLR8. It's instantiated into the top level of the FPGA itself and provides the interface to that top level. The XB address pack is the file where we specify the configuration register addresses that we're going to be using within our custom logic. Those custom registers are determined by the user, but we need to assign addresses in the AVR address space in order to communicate with them. And the Accelerate Wrap template is a template file that we use to add the configuration data bus interface to the user's custom logic. And this is the bus that we use to communicate from the AVR core to the OpenXLR8 logic. The other library that's required is the XLR8Core. As I said, this contains all the libraries, IP blocks, source files that are needed for any of the OpenXLR8 implementations, a set of common files. And again, we're using that extras directory. And in there, we've got a model sim Windows directory that contains files to support simulation. We've got a Quartus directory where we'll find QXP files, which are IP blocks, precompiled IP blocks. We've got more Quartus settings files and synthesis files. And then in the RTL directory, we've got all the Verilog source code that's required to build the entire FPGA image. The methodology itself is 10 steps. What we first do is we copy our build template to Accelerate Build, because that's the location that the IDE is expecting to find the files. Now we're going to copy our unique RTL source files into the Accelerate Build Extras RTL directory. Then we'll take our custom logic and wrap it with our Accelerate Wrap template, which adds the configuration register interface to our custom logic. Oftentimes we'll rename the Accelerate Wrap template something else at this point, because that's not really a good name once you've actually used it. Once we've got that wrapped, now we're going to instantiate that into our OpenXLR8.v, and this actually provides the interface directly to the core of the FPGA, the AVR core, the input and output pins, and interrupt logic. Next, we'll modify our XB address pack to add in our custom register address definitions so that the hardware will know which addresses we're locating our registers at. Moving over to the Quartus directory, we need to modify the OpenXLR8.qsf file to tell Quartus where to find our custom logic files that we're adding to this design. And at this point, we've got all our modifications done to the source files. So we'll launch Quartus and load our project file, the QPF file, for the board that we're targeting. Compile the design, and then convert that compiled design into the RPD format, which is what the IDE requires. And finally, we'll launch the Arduino IDE, and within the IDE itself, we'll run a program to load the new FPGA image directly onto the Accelerate board.